Alright, Electrostatics grade 11. So this question in a final exam is question 6, sometimes question 7, somewhere there. So let's get to business. Question 6. A small metal sphere P is placed in an insulated stand. The sphere carries a charge of -4 nanocoulomb. So before we go far, first we must check how to convert nanocoulombs to coulomb, microcoulombs to coulomb, picocoulombs to coulomb. So let's start here. Nanocoulomb, that means we must multiply by 10 to the -9. Then the answer will be in coulombs. So microcoulomb, just multiply by 10 to the -6. The answer will be in coulombs. So picocoulomb, we just multiply by 10 to the -12. Then the answer will be in coulombs. Right. So now we see -4 nanocoulomb as our sphere P there, placed on an insulated stand. So maybe they might ask why the sphere or the spheres are placed in an insulated stand or a wooden stand. So the answer is they want to prevent the leakage of the charge to the ground. So okay, 6.1, they said stated the principle of conservation of charge. So the principle of conservation of charge, we did this one in grade 10, right? So it states that the net charge of an isolated system remain constant during any physical process. So we can answer that one. 6.1. The net charge, let's move this one. The net charge of an isolated system remains constant during any physical process. So this is how we state the principle of conservation of charge from grade 10. So 6.2, now calculate the number of electrons in excess on sphere P. So this one, normally we don't just answer the question. First we must go to the formula sheet and take the formula straight from the formula sheet. Why are we doing this? Because we want to prevent, or we want to avoid writing the wrong formulas. So that means that we must go straight under electrostatics. So this is the formula sheet. So you make sure that you go to the formula sheet. Don't just write the formula from your head, because you might mess up the formula. So the question said we must calculate the number of electrons. So we come here under electrostatics. That's where we're going to find our formulas, because our topic is electrostatics. So this is the number of electrons that they're talking about. So that means this is our formula that we're going to use now. So 6.2, number of electrons equals to the charge over the electron charge. Now, what is the charge? The charge is -4. So this is -4. Then it is in nanocoulomb. So we must convert this one. Nano, that means we must multiply by 10 to the power -9. So we multiply by 10 to the -9, and then we divide. So this one, this is the charge, or the electron charge. So we have a table here that says this charge is -1,6 times 10 to the -19. So this one is constant. So it's from the table. Then the answer here is going to be, this one's going to give us positive. So remember, the number of electrons must be always positive. This is the number. So the number must be always positive. So from this one, we found out that the answer is 2, 5 times 10 to the power 10. Then this is electrons. We must calculate the number of electrons. So make sure it is in electrons. We have no unit here. So you are calculating the number of people. That means the answer is 5 people. So here is number of electrons. It means that it must be 2, 5 times 10 to the power 10 electrons. So you can write electrons in full. That's not a problem. So there is a second statement here that says a second identical metal sphere Q carrying a charge of positive 3 nanocoulomb is placed, let me push this, is placed 4 centimeters from sphere P as shown in the diagram below. So here now we have sphere P and sphere Q. So they are placed 4 centimeters apart from each other. So 6.3, there's a state Coulomb's law in weights. So Coulomb's law states that the magnitude of the electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So let's not state here because we want to save time. Right? So let's make this one 6.4. So be careful when you state, because on the definition or the principle or the law, if it's 2 marks, it's either 2 marks or 0. There is no 1 mark. So be careful with that one. So now 6.4 is the force that sphere P exerts on sphere Q, a force of attraction or repulsion. So here we have like charges and unlike charges. Like charges is either positive and positive or negative and negative. Those two charges, they are going to repel each other. But if there are unlike charges, positive and negative, these two charges, they are going to attract each other, right? So between the like charges, since they are going to repel each other, it means that between those two forces there is a force of repulsion because they are repelling each other. So if it's unlike charges, between the unlike charges, since they are going to attract each other, it means that the force between these two charges is the force of attraction. They attract each other. So let's check here. We have -4 and +3. These are unlike charges. It means that they are going to attract each other. So since they are going to attract each other, it means that the force is the force of repulsion. It's the force of attraction because they are attracting each other. So it means that this is the force of attraction. This is the force of attraction because these are unlike charges, right? So another statement now. The spheres are now brought into contact. So this is very important. They are brought into contact with each other and then returned to their original position. So what you must know is, even if you didn't read the question yet, just know that once the spheres are brought into contact, when they separate, they are going to form a new charge. That means you are required to calculate a new charge, even if you didn't read the question that is coming yet. Just know that once they are brought into contact, they form a new charge. So now let's check 6.5. 6.5. The question said calculate the new charge on each sphere. Can you say that? So calculating the new charge, we're going to say Q new is equals to charge 1. Since we have 2 spheres, so it's charge 1, the charge on the first sphere, plus the charge on the second sphere. Then since we're having 1, 2 charges, it means that we're going to divide by 2. So now what is the charge on the first sphere? The charge on the first sphere is negative 4 nanocoulomb, but we convert that one, remember? So this is negative 4 times 10 to the negative 9 plus the charge on the second sphere is positive 3, so that is 3 times 10 to the negative 9, and then we divide by 2. So this is negative 4 plus 3 is going to give us, or we can say 3 minus 4, that is negative 1. So negative 1 divide by 2, that's going to give us negative 0.5 times 10 to the negative 9 coulomb. So it means that this is the charge on each sphere after they were brought into contact. So now 6.6, you calculate the magnitude of the electrostatic force now exerted by sphere P on sphere Q. So since now we have a new charge, you forget about the old charges. Now the focus is a new charge, so we forget about the old charges now. Since we have a new charge on sphere P and sphere Q, which is negative 0.5 times 10 to the power negative 9. So now we must calculate the electrostatic force. So this is 6.6. Let's divide here. 6.6. So electrostatic force, O, we are going to the formula sheet. Since we are under electrostatics, this is the force, electrostatic force. Remember, it's having 2 charges, so this is our formula now. Right. So the electrostatic force is equals to K Q1 multiplied by Q2 over the distance squared. So now K is constant. This is Coulomb's constant as 9 times 10 to the power 9. And then charge on Q1. Since the new charge is 0.5 times 10, so we ignore the negative. We found the negative 0.5. That means we ignore the negative here. We have 0.5 times 10 to the negative 9. And then sphere P or Q, okay, sphere number 2, that is also 0.5 times 10 to the power negative 9. So divide the distance. The distance is 4 centimeters. So centimeters to meters. This is 4 divided by 100. So it's going to give us 0.04 meters. So here is 0.04 meters squared. So it's equals to so the answer is going to be 1.41 times 10 to the negative 6 Newton. So be careful with the question. The question said calculate the magnitude. So they are interested on the magnitude, they are not interested on the direction. So this is the answer for 6.6. Now let's check 6.7. 6.7 says that by what factor will the magnitude of the force in question 6.6 change if the distance between the spheres is a half? So since electrostatic force is inversely proportional to the square of the distance, it means that once we half the distance, this is 6.7, once we half the distance, it means that the force is going to be 4 times, because we half the distance and then we square it. So the force is going to be 4 times. So it means that the magnitude of the electrostatic force, or the magnitude of the force, the magnitude of the force will be 4 times Because we half the distance and then we square it. Once we half it and then we square it, that force is going to be 4 times. You can prove that if you have time. So this